So guys, if you remember last, what we did was we came up with this graph. This was the graph which we came up. I'll just run this code. Okay, and okay, ggplot. Again, I have to run everything. So let me execute everything from beginning. There's 3 lines. Then I'll include the library. Let me complete this first and then we'll run it. Tidyverse, sorry. Then tidyr is there, the 2 packages. Basically, you will find that if you install tidyverse, it includes tidyr as well. Okay. But if there are some functionalities which are not working, then please include your tidyr. Okay. Then we executed this. We included the ggplot. Okay, this was the first plot which we plotted. Now this is not looking good because let us zoom this. Okay, this was the plot. I'll just quickly run everything. Then we created this. We got this ggplot, the other one. Okay. Then S for loop. D3 we created. Okay, and then D4 we binded it. D2 and D3 was combined together. We gave the names for the columns. We removed this scope column from here, from DF4. Okay, this was the plot. Then the second one. Then we created df and we added, mutate function is to create new columns, and we created some new columns, match.diff, reading.diff, science.diff, and so on, total as well as average difference as well. And this was the last, I think, diagram which we had drawn. So I'll just zoom this. Okay, if you want, you can increase this as well. Okay, so we had plotted this graph for our males better at maths. Okay, and if you look at this, this is the line, this is the, you can say, mean which we had drawn. Okay, so if you look at the function also, we had put a black line for mean. Okay, and while calculating the mean, we had mentioned the size and the color of the line as well. Okay, and the observation which we could find, or the insights which we could find from this particular example or graph, was that males are performing better in maths compared to the females. And especially if you look at the countries, okay, you can see that the developed countries, in the developed countries, males are performing better. Whereas one more finding was there, that especially for countries like, Singapore and, even Greece, you'll find that the difference between the male's performance and the female performance in maths is literally 0 there. The difference, you can see it's very small, you can say a bar which is coming here. That shows that there's hardly any gap in the performance between the two groups. Okay, and it's a very good insight, or you can say a very important insight, especially for the policymakers who would like to reduce the gap between the performance of the males and the females. Okay, especially in case of the education field. We can make use of, I'll just close this graph, and we can also draw the similar type of graph used for reading, the reading score and the science score. So I've just copied pasted here the same function, and we have changed the columns. Okay, and we got some insights from there as well. Okay, and we have observed one more thing, especially in case of reading. Okay, the females are outperforming the males. So it is one of the areas where males can improve, you can say, that is reading. Again, in science, we found that males are doing better. Okay, this was some few insights. Let us go ahead and just 1 minute, guys, just 1 minute. Okay. So let us go ahead and plot a correlation plot as well. Okay, a correlation plot, especially when we want to find out whether there's a relationship between any two variables or columns in this case. Then we can make use of the correlation plot and the p-values. We can find out the p-values. And the p-values will give me an idea whether there's a high correlation between the two variables or no. Okay. Now to do that, first of all, plotting a correlation plot is very simple. Now for that, I need to get some columns first. I don't want all the columns. So let me first of all look at the data. We'll use DF. Okay, I'll get the first column, that is the name of the country. I'll the second, third, this is for your females, males. Okay, so I'll get country name. I'll get math score for females, math score for males. Similarly, for readings, I'll get the two columns. Okay, let me write the code and get new columns. So I can just write df underscore temp. Okay, equal to df square bracket. Now in this, I want all the records, so I won't give the first parameter. The second parameter is I want to select only the relevant columns. So here I'll give C into bracket, the first one, comma, the third and the fourth. Then just let me check it out. So this is third, fourth. This is the sixth one, seventh one, 9 and 10. Okay. So I can give 4, 6, 7, 8 skip karenge, 9, 10. Okay, these are the columns which I want, so that I can see the relationship between these fields. Okay, I'll just run this. Okay, now to create the correlation plot, we are simply going to make use of the function called core. Okay, it is for getting the correlation. So what I'll do is I'll write res, that is for result, equal to cor into round brackets. The parameter is the data frame which we have just created. Okay, so I'll give df underscore temp. Now there's one small thing which I have to do here is, if you look at the country name is a text field, so there is no value, there's hardly any relationship which I can establish between that column and the other column. Okay, so I need to skip the first column. Now to skip the first column and include all the rows, again I have to give square bracket. I'll skip the first parameter, and to remove or you can say to avoid the first column from the correlation plot, I can give here -1. Okay, so -1 is going to ignore the first column here. Okay, so it is not going to use the first column for the calculations. Okay, I can run this one. Okay, and let me display it. So if I display the value of res, okay, I get this values here. You can see this one. Fine. So this is, and it is showing you the relationship. This is the value. So the math score and the female score, it's 0.98 and so on. Okay. Now what this values, before checking whether there's any correlation between the two fields, if I want to exactly know, okay, we can calculate the p-values to see whether the correlation is significant or not. Okay. Now to check that, there is a package which we need to include. And remember that the smaller the p-value, the more the significant is your correlation. Okay, so it has to be, towards zero. The value should move towards zero. The closer to zero the value is, the higher the correlation. Okay, that is the funda of the p-values. Now to get the p-values, first of all, you need to install one package, which is your H. Let me check whether it is there first. So we'll go to packages here, and we'll search for that package. It starts with HMIS. Okay, this is your package. Okay, so I need to include this. So I'll just write here library into bracket HMMIS. Okay. Now this has to be included. So now if it is not installed, please see that you install this library package as well. Okay. It might take some time to load. Okay, fine, done. So it is included now. Now, once it is included, I can make use, there's a function which is R core, CORR. Okay, so that gives me the P value. So let me write RES, say 2 equal to, okay, function RCORR. This is the function. Okay, it computes the values, especially the P values. And they are going to make use of the Pearson's R, or you can say the Spearman's row mark. Okay, rank. Now, this is more technical into statistics. So if you're interested in learning more on statistics, please do go through some, topics on correlation and especially your calculations, your normal distribution, and so on. That will give you a fair idea about what this values and how it is calculated as well. Now, I'm not interested in how it is calculated right now. So I'll just, pass on the data frame now, because it takes a matrix. So I need to convert my data frame into a matrix and then pass it to this function. So I'll convert this using as.matrix. That's the function, if you remember, and we have to pass the data frame without the first column. So again, df underscore temp into square bracket, all the records, and minus the first column. Okay, so this will give me, I'll run this one, no errors. Okay, RES2, I can display this. Fine. Now you can see now all the values are coming to 0 here. Okay, that means as you can see, there's a high correlation between the variables. So especially in this example, all your variables are correlated, you can say. Okay, closer to 0, it is highly correlated. Fine. So actually, I just wanted to show you whether we can get the correlation plot and the p-value. That's why we have gone through this. Okay, with a different example, you'll find this values can be different. Okay, so wherever there is no correlation, you'll find the values, but it's not moving towards 0. It's not closer to 0. Okay, away from 0, the correlation is less. Okay, or weaker correlation, you can say. Okay, now we can also plot a graph for the correlation, and there is a library called core plot. Okay, which again we can just check it out whether we have it installed. So CORR. Okay, this one. So I'll include this here. I'll just write the code library, and I'll include the CORR PLOT plot. Okay, include this. It is loaded. Okay, I'll plot a graph. So I need the function called core plot. This is a simple function which will plot the values, and the darker the color of the you can see the circle which I'll be plotting here. I'll be using circle. Okay, and that is the default one. And the darker the color, you can see the higher the correlation. Okay, now in this example, because all are zeros, I'll get all the circles in the same dark color. Okay, so light difference might be there. So because we are going to make use of this correlations RES, so I'll use RES, comma, then let us change the order of, or let us put the color, and the method will be, different types are there. Like we have the circle, the square, ellipse, and so on. By default, it will be circle. I'll keep that as it is. Let us give the type. So type equal to, I'll put the upper corner. So from the uppermost, you can see this will be upper. Okay. Then we have the order. Okay, so it will be horizontal clustering type. So I'll give order equal to Now H raster. Okay, let me keep this also in double quotes instead of single quotes. Okay, just to keep it uniform. So in comma, I'll put it on the next line here. Now the color, let us put column say EL dot. So this is your positioning. You can say not positioning the color of the text label which I want. So this I'll give as let us say put black. Okay, you can give this. Then we also have TL dot SRT. This is for your text string rotation. If I don't want it to be sideways, because what will happen, it is going to overlap. So let us rotate this by some degree. So I'll give SRT, especially the text will be rotated in this case. So I think 45 would be better. Okay, and let us run this one. This much is enough. Okay, this spelling mistake, R upper and RES core plot. Fine, let us run this one. Okay, here you can see this is my plot which is got plotted here. Okay, now this is because of that rotation which I have done. Okay, and it's starting from the upper corner here. So from 1 it is starting and it's going down here. Okay, this 0 here. Okay, so all the values which are on the positive sides are coming here. Right? Now, because if you look at the colors also, there's very slight difference in the color. And whenever you see this, because this value is highly correlated, because this both are the same, you can say fields. So that's why you can see this colors are darker compared to the other one. Now this one is a bit lighter, okay, compared to this one. Right? But because all the columns are highly correlated, it is hardly going to give me any different view. Okay, so just for an example, like how we can create a correlation plot as well. Fine. And remember, the stronger the color or darker the color and bigger the size, the higher is the correlation. Okay, the result would be similar to the one which we got above. Okay, because all the variables are interconnected or correlated here. Fine. Let us go ahead and try to formulate some few more things. We are going to use one package called Grid Extra, to plot multiple plots in one go. Plus, we'll look at the simple box plot. I want to create a simple box plot, and we'll refer to that values also. So to get a box plot, I'll check only some few columns I'll use, and then I'll draw a simple box plot. And from there, we'll try to build on that particular block. And I also want to find out, the values which are, outliers values, which either is very extreme values, either towards the minimum value, or, towards the higher side or the lower side, you can say. So we will also try to plot a point, especially on the box plot, which will give me only not all the points. Like last time, what we did was we had plotted all the points. Now I don't want to plot all the points. I just want a simple box plot, and I also want to find the outliers as well. Outliers will be, especially outliers. I also want to display the name of the country, which are the outliers. Okay, so let us draw a simple box plot first. And for that, I'll create another data frame. I don't want to use the previous ones. And here I'll be making use of the calculated field which we had done, the percent difference for maths, for reading, and for science. And I think those are the last few columns. So let me come here. So this 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can see the 11th column, 11, 12, and 13. I want to use this 11, 12, and 13. Okay, that will give me the match difference. And using this, I can draw the box plot. And of course, I would like to have the country name also. So I'll create a data frame DF. Let us create DF. We have 4 here. Okay, so I'll create 5. df5 equal to df into square bracket, and all the records, columns I have to mention 1, 11, 12, and 13. Okay, this is the column. Okay, I get this df5. Let us see this column here. So here we have the country name, we have the match difference which we have got. Okay, negative value indicates females are not performing well. Please remember positive values, difference. Okay, reading difference and match difference. So I'll close this one. Now let us draw a simple box plot and box plot. Okay, and now I'm not using ggplot. Please remember, I'm using a simple box plot. Fine. And now the parameters we have to pass here is the value. So df5 with the dollar sign. Let us use match difference, comma df5 dollar. Will use reading, and finally df5 dollar science difference. Okay, 3 values. Then I'll give some title for this particular box plot. So I have to give use main. I hope you remember all this. Main equal to, and you can say we ask a question, are males better than females? Okay, that's my question, which I'm putting as the title for the chart. Then I'll give the names that has to come. So in the axis, so I give names equal to, and we have 3 subjects, maths, then give a comma, second one reading, and the third one science. Okay, this is enough, and we'll have a color also. So I'll give color. COL is the function equal to, let us give some color. Let us I'll give blue color. Okay, that's enough, and I'll run this one. And that's my chart, a very simple box plot. Okay, now in this, you can see this round circles here. These are my outliers. Okay, now on the upper side, we don't have any outliers here, but especially in reading and in science, we do have outliers. Okay, now as I explained you last time also, the box plot, I hope you have gone through some article to understand what the box plot represents. Now to just give you a review of it, this particular box which is there in the center here. Okay, this is from your first quartile to the third quartile. So 50% of your distribution, actually, if you represent this in a normal distribution, your 50% of your data is lying here. Okay, 50% of your data is lying here. So if you just look at the data, the remaining values are here. Okay, and beyond 99.99 something is all this other outliers, and these are your whiskers. So you have the minimum value. This is your maximum value. Okay, minimum, maximum. This is my first quartile. The line indicates your median. Okay, and this is your third quartile. Okay, so you can say Q1, Q3, min, Q1, median, Q3, and maximum. So there are 5, you can say, parameters through which this box plot is created. Okay, let us come and modify this further. Fine. Now what I want is I want to put some subtitle, the title for the axis, and so on. And I also want the color of the outlier to be changed. So let us quickly do that. Now I'm going to make some changes in my pivot table, especially the table, because I need the maths score and the values. I want all the columns which we had. So let us come back to DF5. Okay, DF5. Now this I want to be a part of you can see the columns here. I don't want this to be the column names itself. Okay, so if you remember, we had used pivot longer last time. So I'll have test diff karke one column, and in that I'll mention this values maths.diff, reading.diff, and science.diff. And I'll have one more column called, let us say, result. And these values will appear in that particular, you can say, column. Okay, so I'll make a small change because I need a better, you can say, box plot. So let me go back and make some few changes here. Okay, so I'll create a df6 here. So df6. Okay, now this will equal to df5. I'm going to make use of the infix operator or the pipe operator. Okay, move this to pivot longer. Okay, the parameters, the columns which I want. So I want to merge, say, the second one, third one, and the fourth one. Okay, so this is one thing I'll do, and press enter. Names, let me give some names. Names for your df6 is equal to, now if you look at df6, sorry, I made a mistake and I did it on df5 only. Okay, so df5 has changed. Fine, it's okay. So I instead of df6 now df5 have to be used. df5. Now if you look at df5 here, you know, this is your name. This has come here. Now I want to change this column names as well. So let me quickly do that. So I've written names into bracket df5 equal to C into bracket. This first one is country. Second one is the test dot difference which we have calculated, and the values will come under results. So I'll give this name as result. Okay, center, and now you can come here and you can see country, test dot diff, and result. Fine. Let us go and create a, okay, we'll create a new column which is indicating the you can see the test type instead of, you know, the difference. We'll create a maths, reading, and so on. So I'll create one more. I'll give new equal to, and in this case I want to repeat the scores because it's in the same sequence, maths, reading, and score. Okay, we'll do one thing. We'll use the repeat function, rep, if you remember. Okay, and I want to repeat some characters. So I want to repeat this maths, comma. Second one is science, no, reading. Second one is reading. And the third one is science. Okay, this I want to repeat how many times. For that, I need to check df4. So we have, this has to be divided by 3. So 6, 68, right? 68. Okay, 68 times. So I'll give a comma and repeat this 68 times. Okay, so it should create a column for me. So press this around. Okay, and I'm going to add this now. So I'll use names. I'll combine this to your df5. So df5 equal to C bind. Okay, because I've created this new, okay, which has maths and so 204 records there. And because I have 204 observations here. Okay, so that's why we gave 68 there. Fine, so combine this to df5 comma new. Okay, now let us change this to 6 so that I get 6. So I have one more and I press enter. Okay, so if I want to see ds6 now you can see now we have country, this result, and this new which we have added. Okay, I don't want this column names. Let us change the column names again. So I give names into bracket df6 equal to C into the bracket. Okay, let me copy this whole thing. Okay, and paste it here. Fine, so country, and I'll give one more. So we have result and we have the test. What type of it is? Fine, now ds6 changed. Fine, coming back. Now let us, the column which we have here, especially this one. Now this one is redundant because it is telling me what type of a test here is. So if you want, you can drop this one, or if you want to keep it as it is, because I won't be requiring, either you can drop it or you can remove it. Now to drop, if remember last time we had done df $6 and this equal to null. Okay, if I execute this one, this is going to drop the column. Okay, I'm not executing that right now. Okay, we'll see if I require it, I'll do that. Now let us make use of the geom box plot to get the box plot and get the outlier also. Now in this example, I'll make use of the title. I'll give subtitle as well. Okay, so geom underscore box plot. Okay, so we are going to use this. Now in this case, I'll pass some parameters. Let us give alpha as 0.7 comma. Okay, I'll explain you all the parameters here. The outlier. Now outlier color, I'm going to change it to, let us say, I'll make it as blue. I'll make some different colors here. So that is the color for the outlier. Okay. Then we need to give the shape also for the outlier. So outlier dot shape. Let us create this as a circle, a filled one. So I'll give 3. Okay, the size of the outlier. Sorry, that was, I think box was 16 or 19 it was. Okay, so I'll get a solid circle with some filled color. And the size also we need to mention so that it comes. So I'll give you, say, 2 is enough. I think 2 is what I'll give. Next, I have to mention the width and let us give that width for the box plot. So width equal to, let us mention as 0.6. I'll give some color. Okay. Now in the color option, we also have some hash values. Okay, there are some values which can be used. So instead of using like, blue, brown, red, green, and all that stuff, the names, we can also use the values. So that can be given using hash. Okay, like for example, I have noted one of them, say 1F3552. Now this is for a color. We'll see that blue type of a color will come here. Okay. Now you need not remember all this. If you want, you can directly mention the name of the color also. Okay. Comma, you can also give the fill color, the fill option, sorry. The fill color, if you want, you can give fill color equal to, again, in this case also, I'm going to make use of some value. So hash 4271 and it was AE. Okay, I'll just show you how it looks like. Okay, let me run this one. Fine, so this is my box plot which I have created. Now this box plot, the setting for the box plot has to be now passed on to your ggplot. Okay, so I've just executed this to check whether there's any error. There's no error here. Now this will be a parameter for your ggplot. So let us give the ggplot function. Okay, the first parameter, the data has to be passed. So data is from df6